Hey, what's wrong with Abby's statement? Well, she said it's 1 out of 2. She's assumed the outcomes are equally likely, and the outcomes are not equally likely. It's a bit like me and my friends playing like a top football team. Yeah, we could win, lose, or draw, but it doesn't mean there's a third of a chance that we're going to win because obviously we're not that great and they're pretty good probably. So you need to take that into account. It's only when things are equally likely you can use this kind of idea. Carl's results give the best estimate of the probability. Why? Well, he's done 100 trials, whereas Abby only did 10 and Ben did 30, so he's got the largest number of trials. And finally, 2 pins are dropped. Estimate the probability that both pins land pin up. Well, let's think about a tree diagram for this. It's either going to land pin up or pin down. And then if we did it again, it's either going to land the pin up or pin down for both of these. So we're interested in this one here, which means we need to multiply these two probabilities. What we're going to use for that probability, well, we've got 2 options. We don't really want to use Abby's estimate of 4/10. You might get away with it, to be fair, but we've already said it. It's Carl's is better, and I would say only doing it 10 times is not a great not a great number of trials, and same for Ben really. So I think we should either look at Carl's 35 over 100, or we could even combine all the results, and that would be 48 over 150. 48 over 150 is a little bit tricky to deal with without a calculator, so I'm going to go with Carl's estimate, which is 35 over 100, and it's going to be 35 over 100. It's going to be approximately times 35 over 100. So now I'm going to need to do a multiplication. Okay, 1,225 over 10,000, and that's going to be, if I divided it by 1,000, I'd get 1.225, so it's going to be 0.1225. Now remember, this is an estimate, so I can't give it to that amount of accuracy, so it's going to be about 0.12. Now you would actually get marks as long as it's in this range here. I did check. So you might, to be fair, even get away with using Abby's estimate of 4/10, which would give you 0.16. You could estimate it in other ways. You could, if we'd done the 48 over 150, you could say this is approximately 50 over 150, which is equal to a third, and then you could have squared that to give 1/9, which would give you about 0.1 recurring in fact. So I'm just trying to say the different sorts of things you could do. At the end of the day, you need to know to multiply them, and you need to sort of use a sensible estimate to multiply.